Hi everyone. In this class we are going to see two-phase method. Solve the following LPP using two-phase method. Minimization of Z is equal to 10x1 plus 6x2 plus 2x3. Subject to the constraints are minus x1 plus x2 plus x3 is greater than or equal to 1. 3x1 plus x2 minus x3 is greater than or equal to 2. So first you have to write the standard form. So the given objective function is minimization of z. So you have to modify that as a maximization of minus z. So minus 10x1 minus x6 x2 minus 2x3. So here the two constraints are in the form greater than or equal to. So you have to subtract surplus variable and add artificial variable. So plus 0 into s1 plus 0 into s2 minus a1 minus a2. So you know that Bingham method only the coefficient of artificial variable will be minus m. In two-phase method the coefficient of artificial variable will be minus 1. So subject to the constraints will be like this: minus x1 plus x2 plus x3 minus s1 plus a1 is equal to 1. Similarly, second constraint is 3x1 plus x2 minus x3 minus s2 plus a2 is equal to 2. So now we have to come with phase 1. So phase 1 already I explained. In phase 1 we have only artificial variable in the objective function. So the objective function is maximization of minus z is equal to minus a1 minus a2. Subject to the constraints are minus x1. So subject to the constraint will be as it is. So you have to write like this. Now we have to come with the initial table. So in the initial table the same thing. For the objective function coefficient you have to write in the CB column as well as CJ column. So only you have the value for artificial variable. The other elements of the coefficients will be 0. So CJ, CB, YB, XB, X1, X2, X3. So here we have three variables and you have to write two surplus variable S1 and S2 and two artificial variable A1 and A2. So in YB column you have to write artificial variable A1 and A2. So you have to write the coefficient means minus 1, minus 1. In CJ also you have to write the coefficient. So 0, 0, 0, 0, 0. Only A1 and A2 you have minus 1, minus 1. And the next you have to use the constraint to fill the initial table. So constraint equation right hand side value will be 1 and 2. So 1, 2 you have to write. So first constraint coefficients are minus 1, 1, 1, minus 1, 0, 1, 0. Second constraint coefficients are 3, 1, minus 1, 0, minus 1, 0, 1. So now you have to find out the Zj value. So Zj value you have to calculate by CB column multiplied with that same column. So minus 1 into minus 1 plus 1 plus minus 1 into 3 minus 3. So plus 1 minus 3 means minus 2. So minus 1 minus 1 minus 2. The next column will be minus 1 plus 1. So the value will be 0. The next is positive 1 because minus 1 into minus 1 is plus 1. The next column first value will be 0. So minus 1 into minus 1 plus 1. For the A1 artificial variable, for this we have Zj value will be minus 1. If our A2 is also minus 1. So now we have to come with Zj minus Cj value. So minus 2, 0, 1, 1, 0, 0. So here we have a tie. So first preference you have to give the first appearance. So first minus 2 you have to take. So that is your biggest, that is the most negative value. So that is your key column. So ratio you have to find out means xb column divided by that key column. 1 divided by minus 1 that is negative value. 2 divided by 3 that is 0.6. So negative means we have to omit. So we have here this one positive integer value that is 0.6. So you have to choose obviously that one. So that is your key row. So intersection element is 3. So A2 is the leaving variable, X1 is the entering variable. So in the next tabular column you have to write A1 X1. So for A1 coefficient is minus 1, A2 coefficient, X1 coefficient is 0. So first you have to change R2 dash. So R2 dash will be R2 divided by 3. So say here the intersection element is 3. So 3 will be, you have to change into 1. So R2 dash is equal to R2 divided by 3. The whole row will be divided by 3. So 2 divided by 3, 3 divided by 3, that is 1. 1 divided by 3 minus 1 by 3, 0 minus 1 by 3, 0. So A2 you have to omit because A2 is the leaving variable. So you have to omit the calculation for A2 also. So R1 dash will be calculated by R1 and the modified matrix, that is the modified row R2 dash. So here we have the coefficient minus 1. So you have to write plus 1. So R1 dash is equal to R1 plus R2 dash. So you have to add the value 1 plus 2 by 3, that is 5 by 3, minus 1 plus 1, 0. 1 plus 1 by 3, that is 4 by 3. 1 minus 1 by 3, that is 2 by 3. Minus 1 minus plus 1, that is minus 1 minus 1. So we have to write, minus 1 plus 0, that is minus 1. 0 minus 1 by 3, so minus 1 by 3. The next will be 1 minus 0, that is 1. So the next we have to find out ZJ value. So ZJ value will be calculated by multiplying xb and that same column. So xb having only one value, that is minus 1 into 0, 0, minus 4 by 3, minus 2 by 3, plus 1 plus 1 by 3. So now we have to omit the A1 calculations also. Now we have to find out ZJ minus CJ. So 0 minus 4 by 3 minus 2 by 3, 1 by 3 will be as it is because CJ values are 0. So no change in ZJ minus CJ value. So for here you have to choose most negative, means obviously minus 4 by 3 is your most negative value. So that is your key column. So now we have to find out the ratio. So XB column divided by key column, that is 5 by 3 divided by 4 by 3. So 5 by 3 into 3 by 4. So 3 will be cancelled. So 5 by 4 is equal to 1.25. Next 2 by 3 into divided by 1 by 3 means 2 by 3 into 3 by 1. That value will be 3 cancel means 2. So smallest positive integer means the first one you have to choose. So the first one you have to take. So that is your key column, key row. So the intersection element is 4 by 3. So the next one is A1 is a leaving variable, X1 is the X2 is the entering variable. So next YB column you have to write X2 into X2 and X1. So the coefficients are 0. Now we have to come with the calculation for R1 double dash. R1 double dash is equal to, here we have the value 4 by 3. So divided by 4 by 3 means 3 by 4. So R1 dash into 3 by 4. So the whole row will be changed, 5 by 4, 0, 1, 1 by 2, minus 3 by 4, minus 1 by 4. So R2 double dash will be calculated by R2 dash and the modified matrix, that is a modified row R1 double dash. So here the coefficient will be 1 by 3. So minus 1 by 3 is the coefficient for R1 double dash. So R2 double dash is equal to R2 dash minus 1 by 3 times of R1 dash. R1 double dash. So the values are 1 by 4, 1, 0, minus 1 by 2, 1 by 4, minus 1 by 4. Now we have to find out the ZJ value. ZJ value will be calculated by XB and the column. So here XB value will be 0. So the whole ZJ will be 0. Similarly, ZJ minus CJ is also 0. So phase 1 will be optimal. So our ZJ minus CJ will be greater than or equal to 0, means the solution of phase 1 is optimal. Now we have to come with phase 2. In phase 2 there is no artificial variable. So you have to omit all the artificial variable in the standard form. So maximization of minus Z you have to write. Similarly, subject to the constraints also you have to write. Now we have to come with the initial table. So in the initial table you have to write the last table values of phase 1. So x2, x1, 5 by 4, 1 by 4 all are equal. Only the coefficients will be changed. So CB we have minus 6, minus 10. CJ is also minus 10, minus 6, minus 2, 0, 0. Now we have to come with the CZJ value. So minus 6 into 0, minus 10 into 1, minus 10. Minus 6 into 1, minus 10 into 0, minus 6. Minus 6 by 2 plus 10 by 2. So 6 by 2 is 3. 10 by 2 is 5. So minus 3 plus 5 is 2. The next will be plus 6 into 3 by 4 plus minus 10 into 1 by 4. So 6 into 3 will be 18 divided by 4 minus 10 divided by 4, that is 8 divided by 4, that is also 2. Minus 6 by 4, plus 6 by 4 plus 10 by 4. That is 16 by 4, that is 4. So Zj minus Cj means 0, 0, 2 minus of minus 2 value will be 4, 0, 0. Here is also all Zj minus Cj's are greater than or equal to 0. Now we have to take the x1 value will be 1 by 4, x2 is 5 by 4 and x3 value will be 0. So minimization of z we have, substituting the x1, x2 and x3 value, we get minimization of z is equal to 10. The next problem is use two-phase method to solve maximization of z is equal to 5x1 plus 3x2. Subject to the constraints are 2x1 plus x2 is less than or equal to 1, x1 plus 4x2 is greater than or equal to 6, where x1 x2 is greater than or equal to 0. So the problem is maximization, so no problem. Here one constraint is less than or equal to form, the another constraint is greater than or equal to form. So less than or equal to form means you have to add the slack variable, greater than or equal to means you have to subtract the subtract surplus variable plus add the artificial variable. So you have to write the standard form. The standard form of the LPP is the objective function's maximization of z. So here we have one slack variable, one surplus variable and one artificial variable. So like this we have to write. So in phase 1 you have to write in the objective function only the artificial variable. So here we have only one artificial variable. So your objective function maximization of z is equal to minus a1. That's all. So subject to the constraints will be as it is. Now we have to come with the initial table. So initial table, first you have to write the slack variable s1, the next we have to write the artificial variable a1. Now we have to write the coefficient for s1 coefficient is 0, a1 coefficient is minus 1. Here you have to change that value will be minus 1, not plus 1. In Cj is also 0, 0, 0, 0, minus 1. So the next will be, you have to use the constraint equation to fill the row, first row and second row. Now we have to find out the Zj values. The first one is 1 into 1, that is minus 1 here. So minus 1 into 1 is minus 1, minus 4, 0, plus 1, plus 1. So Zj minus Cj means minus 1, minus 4, 0, 1. 1 minus of minus 1 is 2. So here minus 4 is the most negative value, so you have to choose that one. So S1 is, here you have to find out the ratio XB column divided by X2. So 1 divided by 1 is equal to 1. 6 divided by 4 is equal to 1.5. So the smallest value is 1. So you have to choose that is your row means. Here S1 is the leaving variable, X2 is the entering variable. So now we have to come with the YB column, X2 into A1, X2 A1. For X2 the coefficient is 0. Here you have to change. Here the X2 coefficient will be 0, not 3. Here the A1 coefficient is minus 1 as it is. So the next you have to find out R1 dash is equal to, already we have a 1, so no problem. R1 dash is equal to R1, so you have to write the values as it is. Similarly R2 dash is equal to R2 minus 4 times of R1 dash. So you have to find out the value 2 minus 7, 0, minus 4, minus 1, minus 1. So the next we have to find out. So similarly for here Zj is also different because here value will be 3. So we have only minus 1 into minus 7 means 7. Minus 1 into 0, therefore there is 0. Next is minus 1 into minus 4, that is plus 4. Minus 1 into minus 1 is plus 1. Minus 1 into minus 1 is plus 1. So students change this one. Zj value will be 7, 0, 4, 1, 1. Again I repeat 7, 0, 4, 1, 1. Now Zj minus Cj will be the same thing, 7, 0, 4, 1. This value will be 2. So here Zj minus Cj value will be greater than or equal to 0, that is positive. But in the last tabular column we have A1, that is the artificial variable will be involved. So we can't go for the solution. So since all Zj minus Cj's are greater than or equal to 0, since one artificial variable A1 appears in the optimum basis at non-zero level, so the given LPP has no feasible solution. So like this you have to conclude. Don't go for phase 2. In the last tabular column we have the artificial variable, means simply we have to write the LPP has no feasible solution. That's all. That is your final answer. So go through it. If you have any doubts, ask me. Thank you.